Now we proceed to the second topic in this chapter, which is about indices. The following are the learning outcomes. So we start with this one. So the index form of a number is the following form. For any real numbers a and m in this form, so we have a as the base and m as the power. So we have a to the power of m. The following are the rules of indices. We have a multiplication operations and so on. For multiplication operations, so we have am times an, we have same base, so we can combine together, and the powers are combined by using the addition operation. So if we have parentheses, okay, like this, the second one, so just multiply n with m, so we have a to the power of mn. For the division operation, because we have a same base, so we can combine together, become single base. For the powers, so we can combine together the powers by using the subtraction operation. So any real numbers to the power of 0 always equal to 1, okay, with one condition, a not equal to 0. A to the power of negative m can be converted, becomes fraction, it becomes 1 over a to the power of positive m. A to the power of 1 over m basically is equal to m root of a, okay. A to the power of m over n actually can be converted, becomes a to the power of 1 over n outside the parenthesis m. So a to the power of 1 over n actually is the nth root of a, so multiply with m, so we have this form. And then we have one parenthesis, outside the parenthesis we have the power n, so that means the power n is applicable to each element inside the parenthesis, or each basis inside the parenthesis. So we have a to the power of n and b to the power of n. So same goes with this one for this fraction. So this n also applicable to both numbers inside the parentheses. Alright, so we start with this example. The question asks you to simplify the given expression. For the first one, it's easy because we are given same bases. We have 3, 3, and 3. So first of all, we combine the bases at the numerator. So we have 3 to the power of 5 times 6 because we have a multiplication operation here. So we combine the power by using the addition operation. So we have 311. At this side, we have again we have same bases 3 and 3, so we can combine together, become single bases, and then the powers can be combined by using the subtraction operation. So the outcome is 3 to the power of 7. Now we move to the second one. In the second example, we have two bases x and y, so we can combine these two bases by using the rules of indices. First of all, 18 and 3 can be simplified, become 6, okay. And then for x, okay, we have the same bases, so we combine together, become single basis x, and the powers are combined by using the subtraction operation. So same goes with y also, using the subtraction operation. So we simplify. So here we still have negative power, so again we can use the rule of indices to convert this expression, become this fraction form. We take x to the denominator side, it becomes positive 2x to the power of positive 2. Okay, this is the final answer. Next is we're dealing with parentheses, as I mentioned before. So the power 2 is applicable to each number inside, or each element inside the parentheses. So it is applicable to 3, it is applicable to x, and also, so this one is y cube. Okay, y cube. Okay, so it is applicable to each element inside the parentheses. So we have 3 squared is equal to 9, x 5 times 2 equal, okay, y 3 times 2, and then we simplify, it becomes 9 x 10 y 6. Okay, now write the following expressions in index form. We have 2 over x cubed. So the solution is, okay, from this form, using the index rule, so we can take x to the beside 2, so the 3 becomes negative 3. And then for the next one, we have 1 over 2x to the power of 4. Okay, again this x to the power of 4 can be converted, becomes like this. So the power for the x becomes negative value. Okay, next We have a parenthesis here, so as I mentioned before, just simply multiply the powers. Okay, we have 4 and half, so multiply 4 and half, the answer is 2. And then again, the same situation here, so this time the power outside the parenthesis is applicable to all elements inside the parenthesis. So we have multiply 8 with half, we multiply 14 with half. So the answer is x to the power 4 over y7. So we can take 7, okay, as negative value. So we have this form. X to the power 4, y to the power of negative 7 as the final answer. Alright. In this example, without using calculator, evaluate the following questions. The first one, 9 to the power of negative 3 over 2. So how to solve this problem? We can solve this problem by trying to make it as simple as possible. Okay, until you can compute the value even without using the calculator. So we have 9 to the power of negative 3 over 2 equal to 1 over, because we have negative sign here, so we have 1 over 9 to the power of negative 3 over 2. So 3 over 2, it is actually equal to 9 in parenthesis, 9 half. Outside the parenthesis we have 3, because if you multiply again, we can get again the 9 to the power of 3 over 2. Okay, so 9 to the power of half means is square root of 9. Square root of 9 is very easy. Without using calculator, you know the answer is equal to 3. So now again, we have a 3 cube. So 3 cube also you can compute by using without the calculator. 3 cube means 3 times 3 times 3. It is equal to 27. So this is the final answer for the first question. In the next question, okay, you are given this kind of fraction. So first of all, we need to convert it becomes improper fraction like this. Okay, we have 36 over 25, and then we have negative sign. Again, we have negative sign. That means we need to convert it becomes fraction form like this. So we have 1 over 36 over 25 to the power of half. So this half, the power half, applicable to each number inside the parenthesis. So it's applicable to 36. It is also applicable to 25. So we have square root of 36 and square root and 25. Both numbers, okay, can be computed without calculators. So before that, because this is a double fraction, so we can change this form to the simple fraction like this. Okay, we change 25 becomes numerator, 36 becomes the denominator. So both numbers can be computed without calculators, so without using calculator. So this is the final answer. Square root of 25 equal to 5. Square root of 36 equal to 6. Now we move to the next example. We have in parentheses 0.04 to the power of negative 3 over 2. Okay, let's see how to solve this problem. So first of all, we convert this decimal number becomes a fraction number. So I think it's very easy. It is 4 over 100. So because we have this negative sign, okay, before that, because this number can be simplified, so we have this one equal to 1 over 25. So 1 over 25, we have negative power, so we can convert it becomes a fraction. So in fraction form, we have 1 over 25 to the power of 3 over 2. Again, 3 over 2 can be converted becomes this form. We put half inside the parenthesis and we put 3 outside the parenthesis. So again, this half is applicable to both values. So we have square root of 1, we have square root of 25. Because we have a double quotient, we can convert becomes this simpler form. So we take 25 becomes the numerator, and square root of 1 becomes the denominator. So we have cube root, we have to the power of 3 here, and then the square root of 25 is 5. Square root of 1 is equal to 1. So it becomes simple. Without using calculator, you can obtain this answer. Alright, now simplify the following expressions. Okay, how to solve this problem? First of all, we are given two fractions and the operations are multiplication. So there is no problem. You can simply multiply the numerator, multiply with the numerator, denominator multiply with the denominator. So we have the following expression. Now we can combine all the bases. Okay, all the same bases. Okay. We can simplify. For example, we have a here, so can be combined by using by using the indices rule. We have b, another b here, we have x, another x here. Okay, we have y, we have another y here. So we combine all these bases, become single base by using all the rules of indices. Okay, in the following case, so from this fraction, we change becomes a non-fraction, so we take -1, okay, this one to whole number, and the denominator to the power of -1. So we take -1 to every entry inside the parentheses, so we have this equation. Okay, so now we have a simpler equation. So now we can combine all these bases by using the indices rules. Okay, we have combined A by using this rule. We combine the powers for the base B by using this rule. The powers for the base X by using this rule, and the powers for the Y base by using this rule. So just simply compute all these values and come out with this equation. So in this equation, we have negative powers. So again, using the rule of indices, we can convert this equation become fraction form. So all the negative powers now becomes positive power. So this one should be the simplest form of the given expression. We have single base for A, single base for X, single base for B, and single base for Y, and all the powers are in positive form. Alright, now we have this example. The same task, you need to simplify the given expression. So first of all, we have this equation. We're aware that this one can be converted becomes this one by using the rules of indices, because we have single base can be separated becomes two bases. Okay, 2 to the power of 2n, 2 to the power of 4, and at the other side, this one also can be converted becomes like this. Okay, the purpose is because we want to get these two entries, these two numbers, 2 to the power of 2n, 2 to the power of 2n. So that means we can factorize. Okay, both parentheses we can factorize becomes this simpler form. We can take out 2 to the power of 2n outside the parentheses. So 2 to the power of 4 equal to 16, and this one becomes 24 times 1 over 4. Okay, so now we can compute the value inside this parenthesis. Okay, compute the value inside the parenthesis. The outcome is equal to 10, and then we can now simplify these equations. This equation, we have 2n, we have 2n, we have 10, we have 10. So finally, the final answer equal to 1. Now find the value of x when we are given 5x equal to 1 to 5. Okay, this is the solution. So we have 5 to the power of x equal to 5 cube, because 1 to 5 actually equal to 5 cube. Now we have 5 here, we have 5 here. We have x as the power, we have 3 as the power. That means x is equal to 3. Obviously, x is equal to 3. Okay, now we have x to the power of 2 over 3, okay, equal to 4. So how to solve this problem? So first of all, we change this form, becomes this form. Okay, we take 2 inside the parentheses, so we have x squared to the power of 1 over 3 equal to 4. And then in this side, okay, in the next step, you want to eliminate the 1 over 3 power. Okay, this one. So how to eliminate that one? So that means we multiply both sides, okay, by using the cube, okay, to the power of 3 to the power of 3 for the both sides. So this one can cancel out, 3 times 1, 3 times 1. So the remaining value is x squared. For this one, 4 cube is equal to 64. Now, our interest is to find x, right? So we need to further simplify this one. So how to convert 2 becomes 1? So to convert 2 becomes 1 is by multiplying 2 with half. So we need to do the same operations to both sides. So this one half, this one also to the power of half. Okay, so this one can cancel out, so the remaining value is x. For the other side, 64 half, that means square root of 64. The answer is plus minus 8. So that is the value for the x. Next is 49 to the power of x square equal to 1 over 7 to the power of 3x minus 2. So our task is to find the value for the x. Okay, let's see how to solve this problem. First of all, so we know that 47 is 7 square. Okay, 7 square. And for this one, we convert from fraction form, becomes non-fraction. So the power is negative 1. So we have this equation. Now we have we just multiply the power. Okay, the power. So we have 7 to x square equal to 7. This one also we can multiply this one with negative 1. So we have 2 minus 3x. So in this equation, we have same bases, 7 and 7. So now we just consider the powers for this numbers. So we have, that means 2x square equal to 2 minus 3x. Okay, for example, 7 cube is always equal to 7 cube. That means the powers are equal. So that means that is why we can put the equal sign for the powers. So that means 2x square equal to 2 minus 3x, because these two numbers are equal. Okay, now, so in this equation, I think it's very simple. We have quadratic equation. We can simply solve this quadratic equation until we obtain the root x equal to half or x equal to negative 2. Okay. Now we have 27 to the power of x plus 1 equal to 9 to the power of x minus 1. So the solution is we try to come out with the same bases, like just provide similar to the previous example. So 27 and 9, so we can convert, becomes the base 3. Okay, so 27 is 3 cube, 9 is 3 square. So we multiply the powers. Okay, we multiply the powers. So we have 3 to the power of 3x plus 3 equal to 3 to the power of 2x minus 2. Again, we have the same bases. Because we have the same bases, so that means the powers are also equal. So we can come out with this equation. Again, we just simply using the algebraic rule to come out with this answer. Okay, so x is equal to negative 5. Now, the example asks you to solve the following equations. The first equation is like this. Okay, so how to solve this problem? First of all, we separate. Okay, separate this one from single base becomes two bases. Okay, the same base, 5 and 5. Okay, and then the next step is okay, the key point here we have 5x. Okay, so we need to do the operations here until we get the same element here, 5x and 5x. Okay, because this one can be further separated, becomes 5x. Outside the parenthesis we have 2 multiply with 5 equal to 6, 5x minus 1. So now we have a common element here, 5x, 5x. The next step is to let the 5x to replace 5x with another value. So let's say we have u. So 5x equal to u. So this equation can be simplified, becomes this equation. After we replace 5x with u, so we have u to the power of 2 means u square multiply with 5 equal to 6. This one becomes u, so we have 6u minus 1. Now the equation becomes simpler to solve. Okay, so we have a quadratic equation. We have this quadratic equation, so it can be factorized, becomes like these equations. So this equation true when one of these equations is equal to 0. So we have this one equal to 0 or this one equal to 0. So we solve. So we have value for the u equal to 1 over 5 or u equal to 1. And don't forget to resubstitute, because our aim is to find x, not to find u. So don't forget to resubstitute the value for the u equal to 5x. Okay, so we have 5x equal to 1 over 5, 5x equal to 1. So our aim is to find x, right? So we have this one, 5x is equal to this fraction can be converted, becomes like this. So we have the same bases, 5 and 5. So x is equal to negative 1. For the other side, 5x equal to 1, 1 also is equal to 5 to the power of 0. Any real number to the power of 0 equal to 1. So obviously we can say that x equal to 0. That's the solution for this problem. Alright, so this problem also has the same strategy to solve. So we have 2x here. So you need to use the index rules to come out with 2x in this expression. So for example, in this example, we can use the index rule, okay, the rules for indices until we come out with this equation. Okay. So in this equation, we convert this one until we have this equation, and this equation can be further simplified, becomes this equation, this expression. So we have 2x here, we have 2x here. Okay, again we can use the substitution strategy. We substitute 2x equal to u, so we come out with a simpler equation. We have come out with a quadratic equation. So we have 4u squared minus 5u plus 1. This is a quadratic equation. It's very easy to factorize, and then we solve for u. Okay, so we have u equal to 1 over 4 or u equal to 1. And then don't forget to resubstitute the value for the u, because your aim is to compute x and not u. So resubstitute u equal to 2 to the power of x. And then we have here 2x equal to 4 to the power of negative 1. 4 is 2 square. And then finally we have 2x equal to 2 to the power of negative 2. Same basis, so x equal to negative 2. Same here, we have 1, so 1 is to the 2 to the power of 0, so x is equal to 0. Okay, so this one also using the same strategy, but this time we are dealing with exponent. So we have e is exponent 2x minus 3e exponent x plus 2 equal to 0. So we are using the same strategy because we have e to the power of x here. Okay, we do some using the rules of indices here. Convert this one becomes this one. So we have ex, we substitute ex equal to u, so we have this quadratic equation. We solve for quadratic equation, and then we have u equal to n 1. Don't forget to resubstitute u equal to ex, and then we have ex equal to 2 and ex equal to 1. Our aim is to obtain x. So how to obtain x? Note that ln of ex equal to x. Okay, we can neutralize this one. So ln ex equal to x. So we put ln at the both sides. Ln ex, ln 2. So ln ex becomes x, ln ex becomes x. Okay, so this one x equal to ln 2. This one also x equal to ln 1. But ln 1, if you compute using the calculator, the value is equal to 0. Okay, so that's the solution for this problem. Now I think the same kind of a question, and also you can use the same kind of strategy. Okay, using the rules of indices, convert the given expression to a quadratic equation like this. Okay, but the key point here is don't forget to resubstitute. Don't forget to resubstitute the value for the u. Once you obtain the value for the u, don't forget to resubstitute and then come out with the final answer. What is the value for the x? Because the question asks you to find x. Okay, in here, for example, we have a 3x equal to 1 over 9. So 1 over 9 is equal to 1 over 3 square. So 3 squared, we convert, becomes 3 to the power negative 2 because of this fraction. So obviously x is equal to negative 2. For this one, very easy, x is equal to 1. That is the solution. Okay.